This is a continuation of part F. We'll just mention a couple more things about this problem. In class, we'll work on using your scientific calculator to do these operations. I'm hoping that you'll try it by yourself and that you're successful. But I should mention that if you don't have a scientific calculator, you can still do it. Now, the only interactive calculator that I have is the fancy TI-84, so I'll show you with that. But the idea is that if 1.5% is taken off, then 98.5% or 0.985 is still on. And so we'd start with our 357, and it is 357,000, and I could type in those zeros if I wanted to. But if I multiply that by 0.985, since that number is less than 1, that's going to go down. And I just need to do that 8 times. And I forgot the decimal point, so we'll clear that one out and start again. So as you see, as we continue to do that, that number continues to decrease. And after 8 times, we do that. We get the same answer. The exponent is fast forwarding that multiplication for you. One more thing we will look at. We'll graph the function and determine whether it's growth or decay, then write a rule for the function, all from 2 points. Now you've got a problem coming up in an assignment where you're given 2 points, and just from those 2 points alone, we don't know for sure what kind of function it is. So the fact that we are told in this problem that it's exponential is very important. If we weren't told that, we would need some other information about whether this is exponential, linear, or even something else. So I will start by plotting those points. We have 0, 4, and 110. Now, since I'm told it's exponential, I know it's a curve, and the way these points are located, if I connect them with an exponential curve, then it increases from left to right. So this represents exponential growth. Now, as far as the rule for the function, earlier in the chapter we did that from a table. So I will make a table. Now, we don't have a lot of information here. But we do have enough, again, because of the fact that we are told that it's exponential. That's our function, or that's our template for an exponential function. You might remember that the first thing we needed to do was find a. And we look at when x equals 0. When x equals 0, y equals 4, so a must equal 4. Again, b to the 0 power would be 1, and the y value is 4, so a must be 4 because 4 times 1 is 4. To find the b value, when x increases by 1, we have to figure out what y does. And specifically, we have to figure out what the y's are multiplied by. Now, if this were exponential decay instead of growth and the y's got smaller, we'd still figure out what it's multiplied by. We would just have a situation where that would be a number that is between 0 and 1. So multiply 4 to get 10. I'm going to set up a little equation. Now that's going to be the number for b, so I'll just use the variable b here. And remember, we have to go that direction because it's what happens when x is increasing by 1. So 4 times the b value must equal 10. The b is 2 5/10. So this part was to get a, this part was to get b. So if I put those numbers into the template, a is 4. Now here's a case where I am going to use parentheses just to be sure that if I were going to use that function, I would be taking the base 2.5 to the x power. So we have the graph, we have the fact that it's exponential growth, and we have the function.